Nobody likes to be hot and uncomfortable. That's why air conditioning is such a popular option on Chrysler Corporation vehicles. Although air conditioning systems have not changed greatly over the years, some design changes have been introduced to improve performance and adapt them to today's smaller, more fuel-efficient engines. To help you test and repair these systems, Chrysler service and product engineers have developed a new air conditioning performance test procedure that helps you pinpoint the source of air conditioning performance problems. Using this procedure, you can correct problems the first time to keep your customers cool and comfortable. All air conditioning systems work on the simple principle that evaporation cools. This is because a large amount of heat energy is needed to change a liquid into a vapor. It takes almost 1,000 times as much heat energy to vaporize a quantity of water as it does to raise the same quantity of water 1 degree. Just as perspiration helps to keep us cool when it evaporates on our skin, the refrigerant vaporizing in the evaporator absorbs heat from the air flowing past the coil. Refrigerant evaporates very readily, so it absorbs heat much faster than evaporating water. The refrigerant leaves the evaporator as a gas and is drawn through the suction tube into the compressor. The gas continues to expand as it goes through the suction tube, absorbing heat energy from the tube and the surrounding air. At the compressor, the refrigerant gas is pressurized. It is then pumped to the condenser. In the condenser, the refrigerant loses heat to the outside air flowing by and returns to liquid form. From there, the refrigerant flows through the filter dryer, where any moisture and contaminants are removed. From the filter dryer, the refrigerant travels through the liquid line. Because the molecules are packed together so tightly, the heat energy left in the refrigerant is concentrated, making the line warm to the touch. The liquid refrigerant begins to vaporize at the expansion valve, which controls the rate of evaporation by metering the refrigerant flow. Vaporization continues throughout the evaporator, completing the cycle. These principles of operation are basic to all air conditioning systems. To help you test and repair all AC systems, there is an air conditioning performance test procedure, which is explained in this service bulletin. It contains the procedures and specifications to help you test for AC problems and correct them quickly. We'll use some sample conditions on front-wheel drive vehicles to show you how the AC performance test procedure can help you when checking for air conditioning problems. Our first condition involves an O24 with a 2.2-liter engine. The customer complaint is no cooling. The first step in any diagnosis is to verify the customer's complaint. The air conditioning is not cooling. Begin testing with the items on the AC system operation checklist. First, check belt tension using the gauge method if possible. Remember that a belt is considered used after it has been on a running engine for 15 minutes. The belt specifications are located in Group 7 of the service manual, Cooling. To perform the next series of checks, start the engine. Push the AC button and slide the temperature control lever to Cool. Begin by checking the compressor clutch to see if it engages properly and to make sure that it doesn't slip. You should be aware that the cycling clutch can be a source of customer complaints even when it is functioning properly. Customers who are used to air conditioning systems that use an evaporator pressure regulator may complain of change in engine speed caused by the normal compressor clutch engagement. A simple explanation may resolve the problem. The next check is for proper fan operation. The fan should come on whenever the compressor clutch is engaged. If the fan doesn't come on, check the fuse. If it is burned out, replace it. And check the fan operation again. As always, when a fuse is blown, trace the entire circuit to find the cause. It appears that the problem with the fan was the cause of our sample condition. When the fan doesn't operate, there is no airflow past the condenser, and therefore no cooling of the refrigerant. Although this is the probable source of the problem, it is important to make the rest of the air conditioning operation checks in case there are other problems. Check the blower motor operation at all speeds. And check to see that the air flows from the proper outlets in each push-button mode. Next, check the sight glass in the filter dryer to see if it is clear and free of foam. The presence of foam indicates a low refrigerant level, which could be caused by a leak in the system. Using a leak detector, check for leaks at all points, including the H valve, the low-pressure cutout switch, the filter dryer, the condenser, and the compressor. Remember that refrigerant is heavier than air, so you must hold the leak detector below the point being tested. Follow the procedures in the service manual and the instructions supplied with the leak detector. This time, there is no leak, so we can assume that the refrigerant was lost through the high-pressure relief valve when the fan failed. Normally, this condition will be indicated by the presence of oil under the hood near the filter dryer. Unlike rear-wheel drive cars with direct drive fans, revving the engine will not increase cooling or AC operation on front-wheel drive cars with electric fans. For the final AC operation checks, feel the suction line to see if it is cool to the touch, and the liquid line to see if it is warm. Both lines are okay, which completes the AC operation checklist. In this case, we've pinpointed the cause of the customer complaint and corrected it without connecting a gauge set to the system. Be aware that many AC conditions can be corrected by making these simple visual checks. Our next condition involves a customer complaint of improper air temperature from all outlets with the AC on. First, verify the customer complaint. The discharge air is not cool enough. So we begin testing with the AC operation checklist. The belt tightness is okay. The clutch engages properly and does not slip. The radiator fan works properly. The blower is okay. And the airflow comes from the proper outlets. The receiver dryer sight glass is clear and free of foam. The suction line is cool and the liquid line is hot. The operation checks haven't revealed the source of the problem, so we'll have to conduct a performance test. To perform the test, you'll need a tachometer, an accurate thermometer, and an AC manifold gauge set. Note that only two gauges, a discharge pressure gauge and a suction pressure gauge, are used instead of the 3 gauges used previously. Connect the discharge pressure gauge to the discharge service port on the muffler, and connect the evaporator suction gauge to the suction port of the compressor. Then, connect the tachometer and close the hood, doors, and windows. Start the engine and set the controls to max AC, full cool, and high blower speed. Raise the engine speed to 1,000 RPM with the AC clutch engaged. Place the thermometer in the left center AC outlet and run the engine for 5 minutes. Then check the discharge temperature and gauge readings and record them. Now, open the hood again and disconnect the gray vacuum line to the heater water control valve. The valve arm should move as the line is disconnected. Plug the vacuum line. With the hood closed, run the AC for 2 more minutes. And check the discharge air temperature again. If the temperature increased by more than 5 degrees Fahrenheit, check for proper blend air door and cable operation. It is possible for the self-adjusting clip to slip so that the blend air door doesn't move to the full cool position. To adjust the cable, follow the procedure in the service manual. This may be the sole cause of the problem. To make sure, we can check our gauge readings and discharge temperature against the values in the appropriate ambient temperature column of the AC performance chart. In this case, the discharge pressure reading is too high. This flow chart in the service manual will help you determine the cause of any variant gauge readings. If you have to evacuate and charge the system, follow the procedures in the service manual. Servicing front-wheel drive air conditioning systems can be easy if you remember the basic principles of system operation and begin your testing with the simple visual checks found in the AC performance testing procedure. You will pinpoint the source of most air conditioning problems quickly and make winners out of both you and your customers.
With the introduction of the new 1982 vehicles with the oxygen feedback system, a new drivability test procedure was developed and sent to you, which will determine what the problem is. A change was made in the 82.5 emission package for the 2.2-liter engine, which affects the existing drivability test procedure. The change consists of a leaner calibration of the oxygen feedback systems. The models affected are the K&L bodies with 2.2-liter 4-cylinder engines and federal emission package. California and high-altitude vehicles are not affected. Before we discuss this new procedure, let's take a look at what components changed in the oxygen feedback system. First, the carburetor has a new calibration. Second, the combustion control computer has new programming for fuel and spark control. These two changes make it possible to operate the engine with overall leaner fuel-air ratio, and as a result, only one catalytic converter is required. In addition to these changes, another hardware change that was made but does not affect the oxygen feedback system is a new AC idle control. It consists of a vacuum control solenoid, vacuum kicker diaphragm, and an overlay wiring harness. The system will increase engine idle speed whenever the AC compressor clutch is engaged. This is accomplished by turning on the vacuum control solenoid, which allows vacuum to enter the kicker diaphragm, which will extend the plunger and open the throttle lever. The overlay wiring harness is connected to the engine cooling fan relay, since it also turns on whenever the compressor clutch is engaged. Now, let's take a look at the test procedure. It has not only been revised to reflect the calibration change of the oxygen feedback system, but it has also been modified with some improvements that should make it easier to find the problem. Here are some of the modifications. First, the testing sequences of the components have been rearranged to improve the flow of diagnosis. Second, some of the system tests have been expanded to simplify the method of checking. Third, new tests, other than the ones which were required because of the change, were added to help find some of these unique problems that occur from time to time. And finally, included with the test procedure will be adjustment procedures and specifications. Next, I would like to discuss some of the items in the procedure that are new or have been changed. Visual inspection. The only change required in this category is the addition of the vacuum hoses and wiring of the new AC idle control system. No start. No changes were required. Drivability test cold. A new test has been added, checking for fuel-fouled spark plugs. The test for the oxygen feedback system vacuum delay switch has been expanded to include the vacuum delay valve. A basic ignition timing check has been added. The cold engine vacuum advance check has been revised, and a new fast idle speed check has been added. Drivability test warm. A new test has been added for checking the carburetor switch. The AC idle speed check has been changed to reflect the new system, and all oxygen feedback system tests have been changed to reflect the calibration change. Now, let's discuss this in a little more detail. As I previously told you, the computer programs have been changed. As a result, the method of testing will be different than vehicles built prior to the change. The best way to show you this is to demonstrate drivability warm test number 13. Connect a voltmeter to the connector at the carburetor green wire and ground. Disconnect and plug the vacuum hose at the computer. Apply 14 inches of vacuum from the auxiliary vacuum source to the computer. Caution: vacuum must be applied before the engine is started, or the test results will be incorrect. Start the engine and let the speed stabilize for 1 minute. Raise the engine speed to 2,000 RPM. Your test indications should show the voltmeter reading between 10 and 14 volts. As you can see, it is now necessary to set in a specified amount of vacuum to the computer, whereas before it was not. This must be done anytime you are checking the operating voltage of the oxygen feedback system. If not, incorrect test results will occur. So follow the procedure carefully during this portion of the test. Also, please note the operating voltage at 2,000 RPM for these 1982.5 vehicles. It is 10 to 14 volts, where previously it was 3 to 9 volts. I suggest you take a few minutes and read through the 1982.5 drivability test procedure. We have highlighted some of the important areas for you. However, thorough understanding can only happen when you use it on a vehicle. If you have any questions, call your technical supervisor. If you have any suggestions or comments, please let us know by sending them in to us using the open-end question form. Running changes are something we all must live with. When they occur and the drivability test procedure is affected, it will be revised to reflect the changes. Please use this procedure with confidence. It works. It will make your job easier, but most important of all, it will keep our customers satisfied. Thank you for your time, and I will be looking forward to our next session.
Meow.